Today we're going to talk about area under a curve, and there's actually two different types of area, and you have to be aware of them, okay? There's what's called net area and also total area. Total area is also considered area, okay? So net area is an integral, all right? And the integral from 0 to pi of sine x this area is actually 2, exactly 2, which is kind of crazy, but yeah, it's exactly 2. This one is also exactly 2, okay, because of the symmetry of it. Okay, so the areas of both these regions are 2. But when we talk about net area, we're talking about accumulating both positive and negative areas. So this is considered positive and this is considered negative because it's below the x-axis. And since they're the same thing, this net area would come out to be 0, okay? So this is net area, and so where we accumulate both positive and negative. Whereas total area, okay, is considered all the areas added up together. So the total area in this case would be 4 because we're going to include both the positive area and the negative area. So when I say total area, that's also just area. So if you hear find the area under the curve, they're actually talking about total area, okay? To use integrals to find this, we're going to have to break this up into the integrals that are above the x-axis for the regions that are above the x-axis, and then we're going to have to subtract the integral for the regions below the x-axis, because if we subtract them, the integral itself will be negative, so we're subtracting a negative value, which will make it be positive, and it will cause it to accumulate. So for instance, right here, all right, this integral from 0 to pi of sine x would be 2. And then we're going to subtract. Now, I know this region's 2, right? But when I take the integral from pi to 2 pi, I know that's going to come out to be negative 2. So this is 2 minus negative 2. So you see how we're going to subtract this negative value. So any regions that are below the x-axis, we're going to have to subtract the integral of the between the x-intercepts. We're going to have to integrate between the x-intercepts, and we're going to have to subtract that integral, okay? So this would be 2 plus 2, which is 4. And once again, this total area, you'll also hear me say just area, find the area. And if you hear me say find the area, that means total area. I will always say net area, okay, if I want you to find just the integral. All right? Okay, so that brings us to the next example, okay? The very first thing we need to do is establish where we're going to stop the integrals, okay? So I know I've given you the graph on this, but I'm not always going to give you the graph, okay? And you shouldn't just rely on the graph, because what if that's off just a little bit and we think it's 3, but it might not be. It will be 3 though, okay? So, but what if you aren't given the graph at all? You're going to have to figure this out. So what we have to do is we have to find the x-intercepts. And in order to find the x-intercepts, that's where y would equal 0, because when y equals 0, that's the x-axis. So this would be 0 is equal to 9 minus x squared. I'm going to add x squared to both sides, and that results in x squared equaling 9. And then I'm going to square root both sides. And this is going to give me two answers, right? X is equal to plus or minus 3. But I'm only considering the function between 0 and 5. So actually, it's just going to be x equals 3. So this point right here is indeed the point 3 comma 0. So to find the area, okay, we're going to have to integrate starting at 0 and ending it where the region is above the x-axis, where it ends, which is at 3. So we're going to integrate from 0 to 3 of 9 minus x squared dx. And now, again, because this region is below the x-axis, we're going to have to subtract the integral from 3 to 5 of the same function, which is 9 minus x squared, and then dx. So one thing that is nice is that both these are going to be the same antiderivative, right? Okay, so this would be, I'm going to put a bracket here. This becomes 9x minus x. I wrote 9x squared. It's just 9x, guys, just 9x. So 9x minus x cubed over 3, and we're going to evaluate that one from 0 to 3, and then minus, and this would also be 9x minus x cubed over 3, and we're going to evaluate that one from 3 to 5. Okay, and this will give us the area of the region, because this integral right here, if we evaluate this, will come out to be negative, and we're going to subtract it. All right, so we need some additional parentheses here, and then a bracket. I'm going to put 3 in here, so this would be 9 times 3 minus 3 cubed over 3, and then minus putting 0 into the antiderivative, so this would be 9 times 0 minus 0 cubed over 3. You guys, one thing I want to say, when you may look at this and go, why write that, Mr. Mitchell? You already know it's going to be 0. Okay, if you do that on a test, I don't know that you know that should be 0. For all I know is you forgot to write it. So if you put this, right, I see that you knew to put it in, and then from there, you don't need to write this anymore, because this is going to come out to be 0. So I'm going to close the parenthesis, okay, and then minus, and then open another parenthesis, and then a bracket, and then 9 times 5, and then minus 5 cubed over 3, close the bracket, and then minus putting 3 in. So that'd be 9 times 3, and then minus 3 cubed over 3, close the bracket, and then close the parenthesis for evaluating this integral. All right, let's start cleaning this up. Okay, so this would equal, all right, this would be, and I'm going to do a parenthesis here, this would be 27 minus, right, because that minus, and then this would be 3 cubed, which is 27 over 3, which is 9. This is going to be minus, this is all 0, so I don't need to write it, so I'm just going to close my parenthesis there, okay? So all of these becomes this, and then minus, and then parenthesis, this would be 45. This would be minus 125 over 3. So I'm working on getting rid of these brackets, okay? This one's going to be minus 27. And because this is negative and I'm going to subtract it, it's going to become positive. And this would be 27 over 3, which is 9. So plus 9. All right. I'm looking at different ways I can do this. I'm just going to go ahead and distribute this negative with each of these. Okay. So this would be, I don't even need the parenthesis anymore. So what we have is 27 minus 9 minus 45 plus, all of these are going to be opposite signs, 125 over 3 plus 27 and then minus 9. Okay, so the 27 and 27 make 54. So you need to be able to do this without a calculator. So that's why I'm just mentally practicing, okay? So 27 and 27 make the 54. And I'm grabbing stuff that's easy to add, okay? So I'm going to put a check there and there because I've already done those. Negative 9 and negative 9 make minus 18. So I've taken care of those. And then minus 45. Okay, and then plus the 125 over 3. Okay, so now with that, okay, so what is 54 minus 45, right? 54 minus 45, that would give you 9 minus 18. So this is minus 9. So this is equal to negative 9 plus 125 thirds. And I need to slide it up, I realize, okay? And so we need to get a common denominator. Okay, and we need to multiply this by 3/3. So this makes negative 27 thirds plus 125 thirds. And then that would give you a value of 98 thirds. And you want to write it like this, not as a decimal, okay? Because that is the exact area of this shaded region, okay? Of the area of the shaded region, the total area, okay? So if you add these two areas up, it would give you that. Okay. All right, let's turn the page and go to the next one. Okay, so for this one, no graph, right? So I don't know what this looks like other than you should know that this is a parabola, okay? So find the total area of the region. So we need to find the x-intercepts in order to know where the breaks are, and then also take a look at the graph, okay? So to find the x-intercepts, I'm going to set y equal to 0. So 0 is equal to x squared minus 7x plus 10. This factors nicely. So this becomes two numbers that multiply to give you positive 10 and add to give you negative 7. And that would be x minus 5 and x minus 2. So that means x is equal to 5 and x is equal to 2. This is a parabola that's opening up. So if you take a look at it, right here is, let's say right there's 2, and let's say right here is 5. And so if it's opening up, it has to come through these, okay? So it's doing something like this. And because this is 5, that's where I want to stop. So I actually want to get all of this region along with this region, right? I want to add this area and this area up. Now, this integral, the integral and the area are the same. This one, I'd have to take the negative of this integral because this integral is going to be negative, okay? So this is the 0.20 and this is the 0.50. Okay, so my area is going to equal the integral from 0 to 2 of my function x squared minus 7x plus 10 dx. Because the next region from 2 to 5 is below the x-axis, I'm going to have to subtract the integral from 2 to 5 of x squared minus 7x plus 10 dx. And once again, this is nice because these are same antiderivative, okay? So here we go. Okay, so the antiderivative would be x cubed over 3 minus 7x squared over 2 plus 10x, and we're going to evaluate that from 0 to 2, and then subtract same antiderivative, so x cubed over 3 minus 7x squared over 2 plus 10x, and then close the bracket, and then from 2 to 5. And so when you're evaluating two integrals like this, it's just really, it is difficult because you got to stay organized and neat. So when I evaluate this between 2 and 5, all right, I'm going to use parentheses and brackets. So this one's equal to, and then parentheses, and 2 cubed over 3, I'm going to use a bracket. The bracket is me putting the 2 in, okay? So 2 cubed over 3 minus 7 times 2 squared over 2 plus 10 times 2, close the bracket, and then minus, and then putting 0 in here. So 0 cubed over 3 minus 7 times 0 squared over 2 plus 10 times 0. Close the bracket, close the parenthesis. Same thing with this one. Okay, so minus and then parenthesis. And now I've got to put 5 in. So I'm going to do that within this first bracket. So 5 cubed over 3 minus 7 times 5 squared over 2 plus the 10 times 5. Close the bracket, minus, and now I got to put 2 in here, right? So 2 cubed over 3 minus 7 times 2 squared over 2, and then plus, and I hate it when I do this. I'm running out of room, right? So plus 10 times 2. Let me grab, I'm going to get a finer pen so I can write smaller, okay? And that's how you do it. You get a smaller pen. All right, so plus 10 times 2. And then close the bracket, and then we should have another parenthesis there. I know that's not the best. I apologize. All right, so let's clean this up a little bit. This is all going to be 0 right here. So I'm going to have a parenthesis here. This would be 8/3. This is 2 squared, which is 4 times 7 and minus. So 2 squared is 4 times 7 is 28. Divided by 2 is 14. So minus 14 plus the 20. And then this is going to be minus, and all of this is going to be 0. So I don't need to write it. So we can just end that there. And then minus, and then in here in the parentheses, we have 125/3. And then this one's going to be, and then we have minus because of the minus right there. Okay. And this is going to be 25 times 7, which is 175 halves. So minus 175 halves plus the 50. And then minus 2 cubed, so this would be 8/3. Because I'm subtracting, this is going to become, this would be 2 squared, which is 4. Let me put a plus. 2 squared, which is 4, times 7 is 28. Divided by 2, that's 14. So plus 14. And then this was positive 10 times 2, right? So I'm going to subtract it. So minus 20. And then close the parenthesis. I would try to clean some of this up, okay? So what we have here is 8/3, and this would be plus 6. And then minus, and I'm going to combine anything that I can in here. So 125/3 minus 8/3, that would be 117/3. You get ugly numbers fast with this, okay? So this would be 117/3, and then minus the 175 halves. And then we have, I would combine these. This is going to make -6, and -6 and positive 50 makes positive 44. Okay, now I would start writing this without the parentheses now. So 8/3. This is the worst one today, okay? 8/3 plus 6 minus 117/3 plus 175 halves minus 44, because each of these is going to be the opposite sign. So I'm just double checking I didn't make a mistake. So these two you could combine, and this makes negative 109/3. These two can combine and make negative 38. So minus 38. And then plus the 175 halves. Okay, so we need to get a common denominator. Unless 3 goes to 109. I don't think it does, though. So I'm going to check it. It doesn't. Okay, so we're going to need to get a common denominator. Okay, so this one I'm going to, because the denominators are 3 and 2, I want a denominator of 6. So I'm going to multiply this by 2/2. So that makes this negative 218/6 minus, and this one I'm going to need to multiply by 6/6, and 38 times 6 is 228. So minus 228/6, and then plus, and this one I'm going to have to get this to become a 6, I'm going to have to multiply by 3/3, and then 175 times 3 is 525. So 525/3. You guys, and I do realize this is monotonous, right? Okay, so we're going to combine these together. Okay, so negative 218 minus 228, and then plus 525. And we get 79. So this comes out to be, and this should be, you know what? This should not be a 3, but a 6. Okay. And so when we add these, we get 79/6. Okay, and that's our answer. The area is 79/6. Now, I'm going to tell you, they will not ask you a question like this on the AP exam because it just takes too long to do this one problem, and you have a limited time. So they're not going to ask. They might ask you a question similar to this, but it's a concept question like, okay, set it up, and you don't have to evaluate it, okay, or something like that. All right, but when I was in college taking calculus, we had to do problems like this by hand, and professors did test us on stuff like this. So you do need to be able to do this by hand. I know it's a pain, okay, but we should be able to do it by hand. And even if you take your first semester calculus class, they usually don't let you use any calculator at all, which is kind of brutal. All right, but that's it. It's 79/6. Okay. So for this next problem, okay, something a little bit different. They want this shaded region, okay? Not the region between the curve and the x-axis, but the shaded region. So we have to think about, okay, all I know how to do using calculus is to get it between the curve and the x-axis, right? That would be this region right in here that I'm kind of, this white region right here. Okay, so how could I get just the gray area? Well, if you look at this, these are nice straight lines, right? So this looks like a rectangle, and in fact it is. So to find the area of this, all right, and this is x equals 1, so it's coming straight down. So we can assume that this is the point 1, 0. And this is the point 5, 0. I started to write 2, 0, but 5, 0. Okay. So to find the area of this, all right, what we're going to need to do is we're going to have to get a bigger region. And if you look at this rectangle right here, that's the bigger region. And we're going to need to remove this oddly shaped region right here, which we can using integrals. Okay. So the shaded region would be equal to, and this would be, we're going from 1 to 5. So this side length is 4. And here we're going from 0 to 5. So the rectangle would be 5 times 4. Okay, so this 5 times 4, which is 20, is the gray area along with this. Okay, this region right here. So what I need to do to just get this shaded region, I'm going to have to remove this from that rectangle. Okay, so minus the integral from 1 to 5 of my function, which the function is this negative x squared plus 6x minus 5. So minus negative x squared plus 6x minus 5. And then dx. And so that's all we're going to have to do is we're going to have to evaluate this integral and we'll have it. Okay. So 5 times 4 is 20. So this gives me an area of 20 minus, and then this antiderivative would be negative x cubed over 3 plus 6x squared over 2 minus 5x, and then close the bracket, and we want to evaluate this from 1 to 5. Okay, so now because we're subtracting, we're going to want to, well, before I even do anything, I want to clean this one up. This simplifies, okay? So this is equal to 20 minus and negative x cubed over 3 plus 3x squared minus 5x. And again, we're going to evaluate that from 1 to 5. Okay, so once again, this is going to be 20 minus, and now I'm going to use, because we got to subtract all of that, right? We got to subtract the evaluation of the antiderivative at 5 minus the antiderivative at 1, and we got to subtract all of that. So that's why I'm going to use parentheses here, and then bracket, and it's going to be negative 5 cubed over 3 plus 3 times 5 squared minus 5 times 5, close my bracket, minus open a bracket to put 1 in. So this would be negative 1 cubed over 3 plus 3 times 1 squared minus 5 times 1. Close the bracket, close the parenthesis. So coming back, this is equivalent to 20 minus, this would be negative 125 over 3. This would be 25 times 3. So this is going to be plus 75 minus 25. This is negative 1/3, but I'm subtracting it, right? So each of these is going to change signs on me. So this is going to be positive 1/3, so plus 1/3. This is going to be minus 3. And this is going to be plus 5. Okay, so then this is 20 minus, all right, and negative 125 thirds plus 1/3, that's going to give us negative 124 thirds. I'm thinking on 124 might be divisible by 3, okay? So then these two would give me 50, plus 5 would give me 55, minus 3 would give me 52. So plus 52. Okay, and so this gives you 20 plus 124 thirds minus 52. Let's see if 24 goes into, or 3 goes into 124. So I'm going to try 124 divided by 3. I can't see anything. There's such a glare. Okay, 124 divided by 3. And it doesn't. Dang it. Okay, so 20 and negative 52, that's going to make negative 32. So this is negative 32 plus 124 thirds. So I'm going to get a common denominator of 3. So this gives me negative, this would be 96 thirds. And then plus 124 thirds. So this gives me a total area of 28 thirds. Okay, so this should give us, if we divided this would give us 9.333. So let me show you. Okay, we can check our answers just to verify, like, did I make a mistake or did I get it all right? Okay, so we could do 5 times 4 and then minus the integral. So alpha window function integrate, which is number 4, and from 1 to 5 of negative x squared. It's gonna be really bad if I got it wrong, huh? I'm pretty sure I didn't. So plus 6x minus 5, and then dx. So yeah, see, we get the same thing. Okay, but see, it won't. Well, sometimes. Let's see. Yeah, so sometimes it won't change it to a fraction for you. Okay, because these are estimates, but they're accurate enough that it's to 3 decimal places. It'll be right. Okay. All right, one more problem that I'm going to show you how to do with a calculator, okay? And then that will be it. So another idea in order to find the total area is another way you could do is look at the function, okay? All right, so right here, just for instance, okay, let's say we want to integrate this from -3 to 3, and the function is y is equal to x cosine of 2x, all right? I would never have you do this right now by hand. In fact, you don't know how to. Okay, so let's say we found the x-intercepts, and this one was a comma 0, and this one was b comma 0, and that's definitely 0 right there. And let's call this one like c comma 0, and this would be 0, 0, and so on. This would be like d0. Okay, so in order to do this the way I just taught you, okay, is to find the area. What we would have to do, we look at this region right here between -3 and a, and it's below. So I'd have to take the negative of the integral from -3 to a of this x cosine of 2x. And then dx. That looks like a 9, but it's really an a. Okay, and then we'd add the integral from a to b because that region's above. So x cosine 2x dx, and then we'd have to subtract, right? And so on. We'd have to go through and do that, all right? But there's another way. What if there was a way in which I could automatically, before I integrate, make all of these areas below become above? And you can do that because if you take the absolute value of a function, all right, you can, what that does is it reflects the part that's below the x-axis over the x-axis. So that's what you're seeing right here, okay? And so because all of the whole graph is now above the x-axis, we can integrate all the way from -3 straight across all the way to 3 because all of it's above, okay? Now, the problem with that is it's really hard to do this by hand. So this is where technology comes in. We're going to use technology to figure this one out, okay? So this is one way. I mean, we just continue on, okay? But this would be another way that you could do this, okay? So to find the total area, we could just take the area and it's going to equal the integral from -3 all the way across to 3. So we wouldn't have to break it up into the areas above and the areas below, in other words. Okay, so the absolute value of x cosine of 2x, and then close my absolute value, and then dx. Because I'm taking the absolute value of the function, which makes the parts below now above, and now all the regions are above, and now I can just integrate across. Okay, so to use our calculator, okay, we would press alpha window and then function integrate. So number 4, and then we would type in -3 to 3 of absolute value. Now, where's absolute value? You press alpha window again, and it's number 1. That's where the absolute value function is. And we type in x cosine, and notice it opened the parenthesis, right? So 2x, and then close the parenthesis for that. And anytime we integrate or differentiate trig functions or inverse trig functions, we need to make sure we're in radian mode, okay? So I am. All right, so we have the absolute value around our function, x, and then we type that in. And we're going to always round to 3 decimal places. This does take a little bit of time. That really takes a long time. Okay, so 5.425. Okay, so this area is about 5.425. And that's another way of doing this. Okay, now you'd only want to do it this way if you had technology. Okay, if you didn't have technology, you'd have to do it this way. Okay, I would never give you a trig function like this that you'd have to integrate by hand, though, because actually, even after we finish this class, you still won't be able to know how to do this integral. Okay, it's actually a BC thing. Okay. All right, it's called integration by parts, but that's something else. All right. All right, guys, you guys have a wonderful day. That's it for today. Okay, so you have an assignment that you need to do. All right, take care, guys.